Hi everyone, this is the second part of my two-part sequence on perfect competition. In the previous video, we covered the perfectly competitive firm's profit maximization process. This video will discuss the company's options if it's earning negative profits, as well as an analysis of the economic impact of entry and exit on prices and profits. Before we get into our analysis of entry and exit in a perfectly competitive market, we first want to examine the two choices that a company can make when it earns negative profits. Should it continue to produce and earn those negative profits, or would it be better for the firm to just shut down and eat its fixed cost? Choosing to shut down effectively means that the firm chooses a quantity of zero. To be sure, a firm earning positive profits would never decide to shut down because earning a positive profit is always better than losing your fixed cost. The company's purpose is to make money, so if you're already earning positive profits, then just keep doing what you're doing. How would a manager make the decision to shut down or to continue to operate despite negative profits? In order to make that decision, the firm must ignore sunk costs, which is money spent that you can never get back. The cost of capital is a sunk cost for the firm because they always have to pay for their machines regardless of whether they produce or shut down. They're not going to get their rent money back, and they're not going to get the money that they paid for machines back. So moving forward, the decision to shut down or to produce depends on how much money you can bring in from sales versus how much it costs you to pay your workers. In other words, the decision to shut down is based on the relationship between total revenue and variable cost. If the company can generate enough money from sales to at least pay their workers, then the firm should go ahead and produce even if they're earning negative profits. On the other hand, the company should shut down if the amount of money that it can collect from sales can't even pay its workers. So the company would furlough its workers and hope that they can find work somewhere else. Because even if they spend their day working for the company, at the end of the day they're not getting paid. So they might as well try to find a different option for work. Now, if total revenue is equal to variable cost, then the company is indifferent between producing or shutting down. So if you could at least afford to still pay your workers, then the tiebreaker is to produce so that you can provide a living for your workers. Notice in this slide that there's a mathematical relationship between price and average variable cost next to the mathematical relationship between total revenue and variable cost. Remember that total revenue is price times quantity, whereas we learned from the cost and production chapter that average variable cost is variable cost divided by quantity. It takes one step of algebra to show that variable cost is equal to average variable cost times quantity. Plugging in average variable cost times quantity into variable cost and price times quantity into total revenue, we've got that a firm should produce, despite earning negative profits, if price times quantity is greater than or equal to average variable cost times quantity. We've got a times quantity on both sides of this inequality, so they cancel out. And we can simplify to say that a company should produce if price is greater than or equal to your average variable cost. This also means that you should shut down if total revenue is less than your variable cost. Using the same logic here, we could say that you shut down if price is less than your average variable cost. We can use this analysis regarding the firm's decision to shut down to connect the marginal cost curve with the supply curve. As we talked about in the supply and demand chapter, the supply curve illustrates the relationship between price and quantity supplied. And we also just found out in the previous video that price is equal to marginal cost for a perfectly competitive firm, since price is equal to marginal revenue and marginal revenue is equal to marginal cost. So another way of thinking about the supply curve is that it is the relationship between marginal cost and quantity. However, there are some quantities that would never exist on the marginal cost curve because a firm would decide to shut down. So what's going to happen is that the supply curve is the marginal cost curve, ignoring any quantity in which the firm shuts down. The next slide will illustrate this idea. I will prove to you that the blue supply curve for the individual firm is a portion of its marginal cost curve. A marginal cost curve is clearly not the same as our traditional upward sloping supply curve because of the dip in the marginal cost curve. But what if I remove that dip in the marginal cost curve? Notice that the blue outline of the marginal cost curve resembles our traditional supply curve. So the question is, how do I ignore this dip? Since the firm shuts down when price is less than average variable cost and price is equal to the marginal cost for a perfectly competitive firm, then the firm shuts down whenever the marginal cost is less than average variable cost. Visually, this means that the firm never produces a quantity where the marginal cost curve is below the average variable cost curve, since this depicts the situation in which the firm would shut down. So if we were to eliminate any portion of the marginal cost curve in which the marginal cost curve is less than the average variable cost, what results is the blue outline of the marginal cost curve. In other words, the blue line is a marginal cost curve where the price is greater than or equal to average variable cost. Again, the blue line looks like a standard upward sloping supply curve. Another important point to make here is that the firm is indifferent between shutting down and producing at the intersection point between marginal cost and average variable cost, because this is where price equals average variable cost. As a result, we call Q0 the shutdown point, since any quantities greater than Q0 is associated with the firm producing, whereas any quantities less than Q0 is associated with the firm shutting down. That was the end of our short-run analysis for perfect competition. What we want to do now is to wrap up this chapter by talking about the long run. Now remember, the difference between short run and long run for cost is that the cost of capital is fixed in the short run but becomes variable in the long run. Well, when it comes to competition, the difference between the short run and the long run is that the number of firms is fixed in the short run but becomes variable in the long run. What this means is that the number of competitors that exist in the industry is fixed in the short run, but over time, the number of firms can fluctuate due to new firms entering the market or existing firms exiting the market. When would we expect to see new firms entering versus existing firms exiting? If you're an entrepreneur and you're trying to decide where to invest your time and money, you're not going to start up a company in an industry that's already losing a lot of money. You don't want to lose money yourself. So instead, you're trying to get into an industry in which the firms are already making positive profits. So in the short run, if firms are making positive profits, we would anticipate entrepreneurs to start up companies in that industry, which would lead to entry by new firms in that industry. On the flip side, we would see firms exiting if they're shutting down not only today, but shutting down tomorrow, shutting down a year from now, and basically shutting down forever. When that happens, that effectively means that the firm has exited the market and no longer exists. To summarize, positive profits should lead to entry and negative profits should lead to exit. Okay, so now what we want to do is to take this idea of firms entering the market and firms exiting the market and figure out how entry and exit would impact prices and therefore profits. This is something that I'm personally really interested in because this is something that I've done research on, but in the context of airlines as opposed to apples. So what we're going to say is that entry is ultimately going to lead to zero profits. Remember, we expect to see entry when, in the short run, firms are making positive profits. So the big punchline here is that entry is going to erode profits and drive profits down from some positive number to zero. Why? Well, let's take a look at this graph. On the left-hand side, we've got the market graph. Supply intersects demand in order to identify the original equilibrium quantity, QE1, and equilibrium price, PE1. On the right-hand side, we've got the individual firm graph. The demand curve, D1, is horizontal at the original market price, P1. We identify the equilibrium quantity, Q1, where the marginal cost curve intersects the marginal revenue curve. We want to start off with zero profits, so my rule of thumb is to draw the average total cost curve to be tangent to the demand curve. Let's suppose that market demand for apples increases for whatever reason, whether it's due to income, taste and preferences, or any of the other demand shifters from the supply and demand chapter. At the market level, this means that the downward sloping demand curve shifts to the right from D1 to D2. Notice that this increases the equilibrium price at the market level. Well, since individual firms are price takers, they'll see that everyone has increased price, and so they will follow suit and increase their price themselves from PE1 to PE2. At the individual firm level, this means that the horizontal demand curve shifts up from D1 to D2. This will lead to an increase in quantity to Q2 since the marginal cost curve intersects the new horizontal demand curve, D2, at Q2. But now the average total cost curve dips below the new demand curve such that PE2 is greater than average total cost. This means that companies are now earning positive profits. In other words, the increase in market demand allows the firms to charge a higher price so that they will go from earning zero profits to positive profits. In the long run, entrepreneurs are going to be attracted to the potential of earning positive profits in this industry, so there will be an influx of startup companies in this space. Since the number of firms is a supply shifter, entry by new firms is going to increase supply, causing the supply curve to shift from S1 to S2. The amount that the supply curve shifts to the right in the market graph is very particular. Notice that the new supply curve S2 intersects the new demand curve D2 at the original equilibrium price PE1. This causes the demand curve for the individual firm to shift back down from D2 to D1, and the individual firm is back to earning zero profits. Although each individual firm produces a lower equilibrium quantity, in the sense that Q2 reverts back to Q1, the market equilibrium quantity further increases to QE3 since there are more firms in the industry. This slide and the next slide summarize the graphical analysis in words. Again, the punchline here is that entry strengthens competition, which puts downward pressure on prices and erodes the positive profits that firms were making. At the end of the day, we would continue to see firms entering the market until the resulting market price causes the firm to just break even. We can do a similar analysis to show that firms exiting the market are ultimately going to cause firms who remain in the industry to earn zero profits. The textbook does not provide a graph for this situation, so here's my hand-drawn version of the graph. On the left-hand side, we've got the market graph. Supply intersects demand in order to identify the original equilibrium quantity QE1 and equilibrium price PE1. On the right-hand side, we've got the individual firm graph. The demand curve D1 is horizontal at the original market price P1. We identify the equilibrium quantity Q1 where the marginal cost curve intersects the marginal revenue curve. We want to start off with zero profits, so my rule of thumb is to draw the average total cost curve to be tangent to the demand curve. Let's suppose that market demand for apples decreases for whatever reason, whether it's due to income, taste and preferences, or any of the other demand shifters from the supply and demand chapter. At the market level, this means that the downward sloping demand curve shifts to the left from D1 to D2. Notice that this decreases the equilibrium price at the market level. Well, since individual firms are price takers, they'll see that everyone has decreased price, and so they will follow suit and decrease their price themselves from PE1 to PE2. At the individual firm level, this means that the horizontal demand curve shifts down from D1 to D2. This will lead to a decrease in quantity to Q2 since the marginal cost curve intersects the new horizontal demand curve, D2, at Q2. But now the average total cost curve is completely above the new demand curve, such that PE2 is less than average total cost. This means that companies are now earning negative profits. In other words, the decrease in market demand forces firms to cut their price so that they go from earning zero profits to negative profits. In the long run, some existing companies will go bankrupt and exit the industry, so there will be a reduction in the number of firms. This is going to decrease supply, causing the supply curve to shift from S1 to S2. The amount that the supply curve shifts to the left in the market graph is very particular. Notice that the new supply curve S2 intersects the new demand curve D2 at the original equilibrium price PE1. This causes the demand curve for the individual firm to shift back down from D2 to D1, and the individual firm is back to earning zero profits. Although each individual firm produces a higher equilibrium quantity, in the sense that Q2 reverts back to Q1, the market equilibrium quantity further decreases to QE3 since there are less firms in the industry. Again, the punchline here is that exit weakens competition, which puts upward pressure on prices and boosts the negative profits that firms were making. At the end of the day, we would continue to see firms exiting the market until the resulting market price causes the firms to just break even. As we just mentioned, positive profits in the short run leads to entry and higher prices so that ultimately firms break even in the long run. On the other hand, negative profits in the short run leads to exit and lower prices so that ultimately firms break even in the long run. Either way, profits are zero in the long run in the perfect competition model. Now that you're done with the two-part sequence, I encourage you to review the practice problems that I provided on Moodle to make sure that you fully understand the concepts introduced in these recordings. Remember that I also provide the solutions to these ungraded problems, and that the purpose of these exercises is to give you an idea of the types of questions you might see on the final exam. As always, feel free to email me with any questions that you have.